beautiful day to you all viewers. You're welcome to this video lecture. My name is Mr. Ibrahim Omotosho Oyebanji, an educator par excellence and a teacher that is committed to equipping the next generation of students into becoming outstanding leaders and global changers. So today I'm going to be teaching you a topic in chemistry titled Empirical, Molecular and Structural Formula. And I shall be grooming you by using calculation questions on empirical formula, molecular formula, as well as structural formula. This is an aspect that is usually tested by most examining bodies. Check through all the years in the WAEC, JUPEB, IJMB question, you see at least a section asking you to solve a question on empirical formula, molecular formula, and structural formula. So today I'm going to be taking you through that journey. So let's take, you take your time to write this question, then I will be demystifying them. So we have, first of all, we have elements present. We have carbon. As we can see in the question, we have elements carbon, we have hydrogen, and of course we have oxygen. Now, element carbon is present. The next is the percentage composition. As we can see from the question, calculate the empirical percentage of oxygen is 58.2%. The percentage of your hydrogen, we have to calculate that carbon is 33.5%. So if we have carbon to be 33.5, 58.2% to be oxygen, total percentage is 100%. So we add these two together, then we subtract it from the total percentage. So what do we have? Total percentage is 100 minus, this is 58.2 plus 33.5. When I add this together, what do I have? 58.2 plus 33.5 is supposed to give me 91.5. So what I have left, 91.7. So what I have left is 8.3. So this gives me 8.3% as the percentage of hydrogen. After we've determined this, the next thing to do is to divide by the relative atomic mass. In most of your RAM represents relative atomic mass. In most of your questions, they would have given you your carbon to be equal to 12, hydrogen to be equal to 1, and oxygen to be equal to 16. So we divide by each of those values. Carbon is 12, so we have 33.5 over 12. We have 8.3 over 1, and we have 58.2 divided by 16. 12 and 13.5, this gives me approximately 2.67%. 8.3 over 1 gives me 8.3, and this gives me 3.5 thereabout. Then the next thing to do after doing this is to divide by the smallest. We divide by the smallest. How do we do that? What is the smallest? 2.67. 2.67 over 2.67. This is 8.3 divided by 2.67. And this is 3.5 divided by 2.67. By the time we divide this gives us 1. This gives us approximately 2.44, which is approximately 2. And this gives us, okay, this gives us 1, approximately 1. So by looking at this, the next thing to do is to write the empirical formula. What is the empirical formula? Carbon is 1, that's C. Hydrogen is 2, CH2. Oxygen is 1, 0. So the empirical formula of this compound is CH2O. That is empirical formula. That is our empirical formula. Number of carbon is 1, number of hydrogen is 2, and number of oxygen is 1. So that gives us carbon 1, C, hydrogen 2, and oxygen is 1. So we move on to the molecular formula. Now there is a relationship between the molecular formula and the empirical formula. And what is the relationship? Molecular formula, which will be designated MF, is equal to empirical formula, that's EF into brackets N. So you can simply say MF is equal to EF into bracket N. So to determine our molecular formula is going to be calculated together to give us our molecular mass. And what is our molecular mass? We have a molecular mass of 180, which is equal to the empirical mass. And what is the empirical mass here? We have CH2O into bracket N. So we go ahead, we have carbon is 12, hydrogen is 1 times 2, plus oxygen is 16. So what do we have? 180 is equal to 12 plus 4, that is 14, plus 16, that is 30, into bracket N. So divide all through by 30, what do we have? 180 over 30 is equal to 30N over 30. 0 cancel 0, this gives us N is equal to 6. So therefore, we have CH2O into brackets N, Abby. Anywhere we see N, we put 6. So what do we have? CH2O into bracket 6. Carbon 6. 2 times 6, that is 12. O times 6, that is O6. So this is our molecular formula. It's equal to the molecular formula. So that is molecular formula. After calculating our molecular formula, the next thing we need to determine is the structural formula. And of course, we have hints from the question already. The question has given us some hints. What are the hints from the question? The question has told us from the last part of the test, on reaction with sodium hydrogen triazocarbonate, there is a rule that when a compound combines with a triazocarbonate, when an acid combines with a triazocarbonate, there's going to be the evolution of CO2 gas. So that concept of colorless, odorless gas that turns flying water milky is talking about CO2. So the reaction with sodium hydrogen triazocarbonate results in the liberation of CO2. So what class of compound, organic compound, will liberate CO2? That class of compound is an alkanoic acid. So that implies that we have a formula C double bond OOH. This is the functional group for alkanoic acid. So how many carbons do we have? We have 6 of them. So this is likely going to be a ketonoic acid. So we have C, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So let's fill in the hydrogen. So that gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is what we have done. Of course, we have 6 oxygen. So this is OH. This is OH. This is OH. That's 1, 2, 3, 4, 5. And of course, we have OH. So from what we can have here, this is 1, 2, 1, 2. So from what we have here, one, 2, 3, 4, 5. So the number of hydrogen is complete as well. So the number of this compound is 1, 2, 3, 4, 5, 6. That's 2, 3, 4. So we have 2, 2, 3, 4 tetra hydroxy. 1, 2, 3, 4, 5, 6. That's what? Hexanoic acid. So, of course, we were thinking this compound is going to be glucose. No, it's not glucose. It is what? 2, 2, 3, 4 tetra hydroxy hexanoic acid. So I believe you understood the concept of molecular formula, empirical formula, and structural formula. Please ensure for more videos, ensure to like our page, subscribe, and ensure to share with your colleagues. Cheers.